So this is Mr. Bruss, and I'm looking at some of the homework problems over section 9.3 for Mr. Sayer's Precalculus class. I've already wrote down some stuff. We're looking at switching from polar coordinates to rectangular coordinates. Polar coordinates, that's when we have a radius and an angle. Rectangular coordinates, that's when we have our traditional x direction and y direction coordinates. To start out here, I looked at and drew ahead of time a small little unit circle just giving us a couple of the values. So when we look for cosine of a certain angle, we'll have it already here. So number 5, we're given -2 4 pi over 3. We want to find the rectangular coordinates. The most important thing when going from polar coordinates to rectangular is we have this equation right here. X equals r cosine theta and y equals r sine theta. Remember, this is our r and this is our theta for our polar coordinates. So all we have to do for this is we just plug in these values. So x is going to equal to -2 cosine of 4 pi over 3, and y is going to equal to -2 sine of 4 pi over 3. 4 pi over 3, that's down in this direction. We'll get that the cosine of that is going to be -1/2. So we're going to have x is equal to -2 times -1/2, and y equals -2. The sine of 4 pi over 3, that will end up being -√3 over 2. So this value right here is -1/2 -√3 over 2. You can also use your calculator to find this, but make sure if you're typing in radians for degrees, then your calculator's in radian mode. So we have -2, -√3 of 2. So last but not least, we're just going to go ahead and write this as a pair. We have x is equal to -2 times -1/2. X is equal to 1. Y is equal to -2 times -√3 over 2. It's going to equal √3. So our final coordinate pair for this is going to be 1, √3. We can box that in. So that is our x, y. This is our angle 4 pi over 3. Now just say that we're going to look at number 17. Here we're given 2, -3, the normal x, y coordinates. We want to find 2 pairs of polar coordinates. So what we want to do is we're going to use the formula r is equal to square root of x squared plus y squared. And to find theta, that's our angle, we're going to use the inverse tan of y over x. Now, first thing I usually do is I usually draw whatever I'm graphing. So 2, -3, that would be 1, 2, 1, 2, 3. We're looking at something down here. So when we're looking for an angle, going for polar coordinates, we're going to look for this angle that's going all the way around this way. So to find our r, we have r is equal to 2 squared, so that's 4, plus -3 squared plus 9. And we get r is equal to square root of 13. R is going to be approximately 3.61. So we already have that. Now we just want to find our angle for theta. We'll do the inverse tan of -3 over 2. When we do that, we get angle is equal to -0.98 degrees. Now what's interesting, usually when we're doing this, we want to find an angle between 0 and 2 pi, or 0 and 180 degrees. So what we're going to do is, because this is a negative number, we're going to go ahead and subtract this from 2 pi. So 2 pi minus 0.98, so this is actually in radians. We're going to get the value 5.3. And we'll label this angle alpha. So this angle going all the way around will give us 5.30. So our first coordinate pair will be 3.61, 5.30 radians. Make sure that when you're looking for radians, your calculator again is in radian degree or radian mode. If it's in degree mode, then you'll find an angle. Now they asked for 2 pairs of polar coordinates, so we found this one right here. What we can also do is we could also find this angle right here and do a negative radius to get this point right here. So what we're going to do is we're going to find this point right here, find this angle, and we're going to give this point using a negative radius from this. And all we have to do for that is we just have to take our first pair, coordinate pair, and just do pi minus the angle. So we'll just label this beta. We'll do pi minus 0.098. And in this we get beta is equal to 2.16. So our second pair is going to be 3.61, 2.16. So here's our first coordinate pair. Here's our second one. And once again, oh yeah, and that's supposed to be negative. So whenever you have a point right here, you know you have your angle and your radius. But in order to find another point that's right here, you can also choose this angle right here, but use a negative radius to get back here. And so what we did is we just subtracted it from pi. Since pi is a 180 degree turn, that's why we used that there. We subtracted 0.98, and then we got 2.16. So 2.16 radians will give us this angle, but because we have a negative, it brings us back to our original point right here. And so that concludes number 5 and number 17 on page 557 for today's homework. And have a good day.